All right, Algebra 2. Welcome back, guys. We are in section 4 today, talking all about hyperbolas, okay? So there will be a pretty close connection with this section 4 information all about hyperbolas, and in the previous section, section 3, which I believe was all about ellipses. Let me double check that. Yes. So the connection with ellipses and now this section 4 with hyperbolas, it keeps going. So it's good that there's similarities, but you want to make sure that you don't get confused with any parts that are specific to hyperbolas and specific to ellipses. All right, so I'm just thinking ahead about the test. And I know that a lot of times when there's connections, then that means your mind just kind of puts it all in the exact same category. And if there's little differences, then it becomes a bit tough to remember that one piece that's different for each part. All right, so that being said, here we go. Let's jump into it. Remember, everything that is highlighted, that's what you have to have. All right, if you write it all down, then you are even better prepared. But I'm thinking bare minimum, everything that you see highlighted. All right, so you got the hyperbola. Remember, we're doing the difference between a point and a fixed focal 1. And then we're doing, again, the distance between a point and then the fixed focal for F2. And then we're going to be subtracting those two distances to get our final solution there for distance. Okay, so this I just described. And then here's the equation that we're using right there. Okay, so that's going to be finding the constant difference for a hyperbola. And then make sure you understand we're in the absolute value, so you're always going to create a positive outcome as your answer. This information that you're looking at right here, this is basic definitions of what a hyperbola actually is, as well as terms that you're going to see in the text, such as the transverse axis of symmetry, and then let's see, the axis of symmetry, and then vertices. And then when we're talking about vertices, you're going to have regular vertices that we're dealing with, and then co-vertices that we're dealing with. And the co-vertices connect to the conjugate axis of symmetry. All right, so conjugate, basically just thinking like opposite of, and then go back to the original axis of symmetry and think opposite. That's going to give you your conjugate. Okay, all right, so that's just some basic terminology. I know it's not really that basic. I get it. These are words you're not using in your daily life, but they are connecting to this section all about hyperbolas. All right, now comes the part that everyone just loves so much, the charts. All right, and unfortunately, I'm gonna want you to have both of these charts fully copied down, because there's nothing more that I'm highlighting within them. I'm just highlighting the entire chart, and if I highlight it, that means it's helpful. And if it's helpful, it could come back on the test. And then, of course, you're going to really wish you had it. All right. So this information right here is all about if you are looking at a given picture, and then they're going to want you to understand what is what here. All right. What's the vertex? What's the focus? What's the co-vertex? All right. And then you're going to be able to see what I'm talking about when it comes to the conjugate axis and then the transverse axis. All right, you have your asymptotes, all that information. I get that it's a bit overwhelming here, but copy it down, and it's going to make connections and make a little bit more sense as we go through the problems. All right, this chart right here, this one is when your center is at 0, 0. Things tend to be a lot easier when your center is at 0, 0. And then here's the chart. I'm going to go ahead and zoom in on that, because you will really need to have this chart when it comes to a center that is not at 0, 0. Okay, so our difference here is look up at the top, and you'll notice that your X and Y's have other numbers that they're dealing with. And if you look here in the I have a 0, 0 chart, there's nothing else with your X and Y's at the top. Okay, so that's going to denote, all right, your center is 0, 0, or you have information extra in the numerator, then your center is not at 0, 0. All right, take the time, copy it down, copy it down. Here we go. We only have 3 example problems, so let's get to it. The first one, finding the constant difference. Remember, it's all about the distance equation, and we are dealing with a point for the hyperbola at 4, 0, and then that point at 4, 0, let's have this be representing the x1 and the y1, which means the f1, we're going to have this represent the x2 and the y2, and then we can say we have another x2 and y2 with a different color. I guess you could go ahead and say that maybe this is x3 and y3. That would work. And then just make sure that you're not crossing things over. All right. All right. Well, let's write it out. Okay. So we have distance formula. And we are going to go ahead and use the point and then the f1. All right. So we have a -5, and that is subtract 4, and then we have our 0 and subtract 0. So that works out easily. Then we're going to be subtracting this from the next distance formula, which goes with our f2 point. And let's get this all set up right here. Okay, so the f2 x value is 5, and then the point x value was 4, and then we go back to the nice 0, 0 right there. Okay, so simple calculation. All right, we're dealing with a -5 minus 4. So that's going to give you a -9. You're going to square it. You're going to get 81. Okay, we know that this part right here, nice and easy, crosses out. We don't have to worry about that. So basically, we're dealing with the square root of 81, which is going to bring us down to 9. And then 5 minus 4 is 1. Squared is going to be the square root of 1, which is 1. And let's see here, giving us 1, and 9 minus 1, giving us 8. Okay, all right, so that's us looking at the difference of a hyperbola, and we're dealing with f1 -5, f2 +5, hyperbola 0.4. So plugging all those in for the distance, then subtract both of those distances together, and we're getting 8. Okay. All right, so let's move ahead into the second example problem, and we're dealing with, let's see, equation in standard form. Okay. And we have a vertex and a co-vertex. All right, so this works out quite nice because we have the information right here. All right, and what I want to address is the fact that we have the vertex and the co-vertex, which means we're given A and we're given B. If they didn't give you A, or separately they didn't give you B, but then they give you the foci, meaning they give you C, then you're going to have to remember to use the equation. I want to make sure I write this down again for you guys. There's that separate equation, C squared equals A squared plus B squared. And that is the equation you use if they give you a foci and a vertice, meaning they're going to give you A and C, or they might give you a co-vertice and the foci, meaning they're giving you B and C. But Unfortunately, to use the standard form, you have to have A and B. So if they give you A and B, which is like what we were given, then it's very easy. But if they don't give you A and B, you have to solve for the unknown. All right, so let's get back to it. They give us A and they give us B. All right, so here's the part where we don't actually have any major calculations to do. We can simply take a look at which vertex are we given. We're given 0 in front, which means we are dealing with a vertical standard form. Again, that's when 0 for the vertex is given in front. That's right here. 0 is given in front for the vertex, so we're dealing with the vertical form. All right, so that means we're going to have y squared over a value minus x squared over a value equals 1. And that value under y is a squared, which our a value is 9. So square it, give you 81. Under our x value is going to be 49 because that's our b value squared. That is all we're dealing with right there. So no real calculation, just conceptual understanding where things go and how to plug them in. All right, last one to do here. We have a center for starters that's not at 0, 0. So the first thing we want to do for our example problem number 3 here is notice that we have a little extra going on in the numerator, which means our center is not at 0, 0. So let's go ahead and first write down the center value, which when you plug them in, you do the opposite. So that means our x value is really a positive 1, and our y value is really a negative 5. And then if you look at the textbook, these values are representing the variables h and k. All right, and that's going to come in handy because when you look back at the chart, which by the way, this is the chart I'm talking about, all right, h and k, and then we want to take a look and see, are we dealing with horizontal or are we dealing with vertical? Okay, and if we go back to what was given, notice how the y value is in front, and if you look back up at the chart, the y value is in front for vertical. So that means we are wanting to deal with everything in this vertical column right here to pull out how to solve for vertices, co-vertices, and asymptotes, because that's what the directions are going to ask of us as we scroll back down. All right, vertices, co-vertices, and asymptotes. All right, the next piece is that we have to pull out what is A and what is B. All right, and how do we calculate that? By taking the square root. So A equals 3 and B equals 1. So we're taking the square root of 9 to give us 3 and the square root of 1 to give us 1. Okay, so now we have all the necessary pieces. Let's go ahead and calculate our vertices. So the vertice says the x value is just h, and what is our x value being h? It's just 1. So we're going to have 1 comma and then a value we have to figure out, then another 1 comma and another value, of course, that we have to figure out. Okay, and we're going to do k plus a. K is negative 5, a is a positive 3. So k plus a is going to give us a negative 2. And then we're supposed to do k minus a. So negative 5 minus negative 3 is going to give us a negative 8. All right, and right here what we were calculating, these are the vertices. Okay, the next thing that we have to calculate is the co-vertices. And again, I'm just using that chart for standard form where the center is not at 0, 0. So the y value for the co-vertices is just sticking with the y value that we had in the center. All right, and now we're looking at h plus b. So h is 1, b is 1. We get 2. Now we're looking at h minus b, and that's going to be 1 minus 1, giving us 0. And that would be our co-vertices. And now the final piece we're looking for is to calculate the asymptote. And if you look up at your chart, really beneficial, guys, we've been dealing this whole time with information right here from this chart. Now the asymptote is right here. Okay, we got y minus k plus or minus a over b, parentheses x minus h. That's what we're dealing with. So let's finish this off and plug in the necessary values. All right, let's do this in a little different color to differentiate here. Okay, so we have y minus k, but notice that k is a negative 5. So really what I'm going to be doing here is I'm going to say this is actually y plus 5 equals a over b. So a over b means really we're dealing with a plus or minus 3. And then parentheses in here, x minus h. X minus, and what is h? 1. All right, now we're almost done because we just have to take this and bring it over to the other side, which is going to make it become a negative 5. And then I'm going to go ahead and erase that. And on your notes, though, I'd probably recommend that you don't erase it. Just move it over so you can see how we created a final asymptote equation right there. Y equals plus or minus 3, parentheses x minus 1, then outside of the parentheses minus 5. All right, so let's go ahead and zoom out. Example problems 2 and 3 right here. Example problem 1 right there. All right, listen up, guys. Bring your questions to class. All right, take it seriously. Again, lots of connections can be very helpful, but make sure that you don't have an overlap with concepts so that you're not confusing things like circles, ellipses, and hyperbolas altogether. All right, you guys got this. Ask me questions if you got them. I'll see you in the next one.